Welcome to Summarize Science. Have you ever wondered how you could take a regular 2D video and turn it into a fully interactive 3D world that moves and changes over time? Creating 3D models from photos is getting easier, but when objects and people are moving within the video, it becomes a massive challenge for most AI. That's because moving objects violate the geometric rules that these systems rely on to understand a scene. To solve this, researchers have developed a new framework called C4D. It takes a single monocular video as input and produces a complete 4D reconstruction, meaning it captures the 3D geometry of the scene as it evolves through time. The secret lies in how it understands motion. It uses a special component they created called a Dynamic Aware Point Tracker, or DynPT. This smart tracker doesn't just follow points in the video, it also predicts whether a point is moving because the camera is moving or because the object itself is actually moving in the world. This allows the system to create accurate motion masks that separate the dynamic, moving elements from the static background. By focusing only on the stable, static background, the AI can get a very precise reading of the camera's movement and position. Then, it combines this camera path with the 3D information of both the background and the separately tracked moving objects. This all gets optimized together to create a smooth, accurate, and consistent 4D representation of the original scene. And the results are quite impressive. When tested on challenging datasets, the C4D framework consistently improved performance over existing 3D-only methods. For example, in this table for camera pose estimation, C4D significantly reduces the error rates, especially on dynamic scenes like Cited. It's the same story for video depth estimation, where C4D achieves top-tier results by producing more accurate and consistent depth maps across the entire video. This qualitative comparison of motion masks also shows how much more accurate and complete C4D's understanding of movement is compared to other recent work. So, to recap the important points, the C4D framework intelligently tracks points in a video to figure out what's moving on its own versus what's part of the background. This separation is the key that allows it to accurately reconstruct both the camera's motion and the scene's changing 3D geometry from a single 2D video. This is a big step forward for computer vision. Imagine the possibilities for the future, creating realistic, moving 3D assets for video games or virtual reality simply by recording a video on your phone. It could also give self-driving cars a much richer understanding of how other vehicles and pedestrians are moving in the 3D world around them. This technology brings AI one step closer to perceiving our dynamic world in 3D, just like we do. That's all for today on Summarize Science. Thanks for watching.